Hey guys, good night. My name is Fernando. I am Brazilian. I did all the trip to came here. It takes me 3 days, long journey. This is my second time here in Japan, but I still don't speak any Japanese. Too difficult. I'll try to speak as slowly and clear as possible, but if you have some questions, just interrupt me, raise your hand, we can talk, no problem. Okay? I'm a Java champion. I run a company in Brazil, a data science company. We have some big data problems, and tonight I want to discuss with you some challenge that we had to solve a few of those problems. One of those problems was related with data science and how to exchange information between our data scientists. We have a few of them in our company, and they usually work alone doing all the experimentations, but they have to exchange the information with each other, and it was a challenge. And another big challenge was related to the big data processing, because we have lots of data, terabytes of data, and those data have to be processed a few times a day. So before I started, who here knows data science and big data? No one? Java? Are you Java developers? No? Developers? No.
Maybe.
Okay. We used a framework called Spark framework. It is a framework used to big data processing and to facilitate the job distribution across a cluster of machines. And also, for the coding and exchanging purpose, we used this tool, this visual tool called Spark Notebook. The Spark Notebook is like the paper notebook that you use to take notes, but you can take notes and execute code inside the browser. What you do here, for example, all this presentation is a live demo. So for this example, this cell has some markdown code. And when I execute this code, I get some visualization right inside the browser. And I can do two things here. I can have this markdown visualization, but I can also have another kind of cell type called code. And I can type real code here and execute this code and have an output. For this setup, I use a big data cloud, Oracle Big Data Cloud, with 3 nodes. It's pretty straightforward to deploy the cluster. You just choose the kind of the development profile you want to execute, if it is a full profile with lots of tools, or just the Spark by itself, how many nodes you want your cluster to have. For this demo, we are running with 3 nodes, the shape of the machine, and the version of the Spark. Then you click next, next, finish, and you have a full cluster deployed, and you can start running all your code. For this demo, you can also clone this GitHub repository. If you clone the repository and start the cluster inside your laptop, you can do all the experimentation that I'm going to show you, and you have the same results on your local machine. This repository has a Docker image. You can deploy the Docker image and start all the cluster locally and do the experimentations yourself. So let's start and see how the data science do all the experimentation inside this tool. And it's pretty easy. The tool uses Scala language, but you only need Scala language to instantiate the Spark context. And when you have all the context available, you can also use Java language or your Java class inside the program. For the context itself, you just have to get a session from the Spark session. It has a builder built in. You give an app name, some configurations, and you have a Spark variable available inside this context. To run the code, you just press the play button, and you have the variable available for you. If you see the right side of the screen, you have all the variables that are available here in this context. Because I gave this talk yesterday, and I already ran all the codes during my presentation. And the notebooks allows me to have all my experimentations inside files. And when I open the experimentation, for example, the Groundbreaker Tour experimentation, I open it. I get the same results as the experimentation that I did yesterday. That's how we exchange data between data scientists. And the notebook itself is just a plain file with some JSON format inside. If I go to File, Download, I can download the Spark notebook. And this is the file. If we open the file, you see a big JSON with all my codes and all my outputs. If I exchange this file with another data scientist and he opens the file inside the notebook, he will have the same output that I had during my experimentation. So he can see the output. For example, I read a CSV file using my Spark context. I read this file. I converted it to a data frame. Data frame is the kind of format that the Spark can manage for you. When I execute this code, I will have a data frame variable available for me. And just below, I have a df.show that can show me the output of my data frame. If I execute this code again, it's quite fast, but you can see it blinks a new table. What this code does, it converts my data frame.show to a compiled code. It sends to the cloud, runs inside my cluster, reads the files, and send the output back to my user interface. And the data scientist can start doing all the experimentations inside the data frame. For example, I can count how many lines my data frame has. And it's quite fast. It took less than a second to send the data to the cloud and get the result back. But as you can see, I already have all the results of my experimentations right here. I don't need to reevaluate the code to see the results because someone else already did it for me. For example, if I want to print the schema that the Spark evaluates when it reads the CSV file, I can use a .printSchema method inside the data frame, and I can inspect all the types that the Spark evaluated for me. As it was a CSV file, we expected all the fields to be string. But sometimes I don't want all the fields to be string. I want to inform what kind of information I have inside a field. So right down here, we created another variable with a structure type to inform what kind of data type I have in each field. And using this variable, we read the schema again, but this time using the schema method and informing what kind of schema I expected this file to have. When I evaluate this code, now I have a new variable record with my new data frame with a proper schema set up. So if we print the schema of my new data frame, you can see that the latitude and longitude fields are now doubles. The accuracy is also double. And when I inform the correct type of information that I have inside the field, I can do some maths and better qualify the filters. And for example, let's try to filter inside my data frame some information using my ID column and this value. And after executing the filter, I'm going to show what the results looks like. You see, it took 1 second to build this code, send the code to the cloud, filter all the information, and send the result back to my machine. And you can do some more complicated informations or methods like sort and filters and sort. And as I told you, you can also run Java code inside the Scala the Scala context. And to do it, the Spark framework allows you, inside the metadata, inform some custom dependencies that you want to load when you start your cluster. For this example, I loaded a custom Java class. It's inside my dependencies repository. When I start the cluster, it reads my jar file, and the Java class becomes available for me. And to execute the Java code, you just inform the package and the method you want to run. And the simple method only tells me the time, but it is a Java code. If you clone this Git repository, you can see the actual Java code that is running here. And also, if you want to run Java code as Spark functions, you can implement your Java class. If you double press the cell as I did, you can see the actual markdown. Let's press play again, and you can see the visual of the markdown. So this Scala class, this Java class implement a user-defined function with 3 parameters. When I tell that my Java class implements a function with 3 parameters, it's gonna execute a call method with 3 parameters. And for this example, I'm using latitude, longitude, and a number of characters to evaluate a geohashing based on the latitude and longitude that's inside my big data file. My big data file is composed of geopoints that we collected from mobile devices, and we have thousands of lines. And I want to convert the latitude and longitude to a big string so we can manipulate this string and do some custom manipulations. And let's see how it works. I wrote this Java class, loaded the Java class inside my Spark file, and now I can register my function inside the Sparker use-defined function register. I give my function a name. It's going to call geohash. The variable that instantiates my class and the data type of the output. Now that I have my gel function registered, I can call it inside the data frame and start doing all my experimentations using my user-defined function. So here, I'm gonna go through all my records and generate a new column called generated gel hash. I call my user-defined function gel hash with 3 parameters. The latitude, that's inside the CSV file, also the longitude, and a fixed integer. The integer is how big I want my string to be. After that, I will select 4 columns for the output. So the final output, this records with function, will have 4 columns with all my user-defined functions called. When I execute this code, it also send to the cloud and do everything again. Send to my cluster, to all my nodes, execute inside my CSV file, and send the output back to my user interface. And now I have my generated gel hash inside this new variable. And I can start doing experimentations using my new gel hash column. If you want to do some more complex calculations, for example, with distinct, group by, and count, sort, I did this new demo because it takes longer. And you can see that the code is running, you have a bar, and you get the result back. If we change, for example, the number of characters that I want here and reevaluate the code, we have a new generated gel hash here, now with 3 characters as a string. And the user interface also has some helpers for visualization purpose. For example, this bar chart, I got my device by gel hash variable. I'm creating a new temporary view from the values that's inside my variable, and I'm sending to a helper called bar chart. And when I execute the code, it plots me a bar chart again. This pie chart was plotted yesterday using 2 characters, but as you saw, I changed my data frame to 3 characters now. If I evaluate this code, I may get some new results now. See, let's change back. And as I'm doing a live experimentation, and my data scientists also do live experimentations, if I change it back to 2 characters here, I'm going to change my Spark context, and now I have a new result. If I reevaluate my charts, you see that now I have a new chart available with small data, and also for the pie charts. And this is live, but the information is not on my laptop. The information is on my Spark cluster, and it's available for me as soon as I don't stop the Spark kernel. The Spark kernel is the actual instance of the Spark that's running inside my cluster. So my laptop is connected to this kernel, and all this context that you see on the right side is available for me, not here, but inside the cluster. So I can close my machine, disconnect from the internet, connect again tomorrow, and my context is available there. If you don't want to write all methods yourself, if you are a SQL guy and you prefer to write some SQL codes, you can also use the Spark SQL language to help you do the experimentation. For example, I'm going to write a select. I will select 4 columns from my records data frame and group by my generated geohash with some precision that's set in this variable. What the Spark does here, it reads the SQL sentence that I wrote here, converts the SQL sentence to a Scala language, and then send to my cluster for evaluation. It's the same as the method, but with a helper with Scala language. There's also a table chart that you can live see your data. Instead of a simple table, this table chart is a live chart. For example, if I search something here and press enter, I can start seeing my data live right in front of me. And we have some kind of performance tuning that we can do this code 3 times. And it took 9 seconds to evaluate this code. But we can apply some persistence, intermediate persistence, because I know that I'm going to use this variable 3 times to improve the performance. So instead of the 9 seconds, let's apply a persistence based on memory and disk. So the Spark will persist all my intermediate results inside the memory. If there is not enough memory, it's going to persist inside the disk. And I will have another intermediate variable, now called persisted. And for this intermediate result, it took 2.4 seconds to execute, but I do not have the results that I need because I have to execute the filters using my persisted results. When I execute it, instead of executing 3 times the same code, it's going to execute 1 time the big code and only the filters here. And let's see if it's going to work. Let's execute the first one. It took 3 seconds. Then the second one. Oops, wrong one. Second one. So it took just almost 3 seconds for the first part and almost 2 seconds for the second part. And this is a simple example, but when we run with tons and tons of data, it's going to save lots and lots of time. And as you don't have unlimited results, as soon as you don't need the information anymore, you just call the unpersist, and it's going to clean up the cluster and free the resource for you. So this is basically how the data science do all the experimentation. And as soon as we finish the experimentation, we can use this code for production purpose, and we can also download the file and send it to another data scientist for sharing the information. I think we have a few minutes if you guys have any questions. Let me know. That's all. Arigatou gozaimashita.